Hello everyone, today I'm going to be going over the concept of limits. Let's get started. Let's get started by considering this function f of x we have over here. Now, we may think that we may be able to simplify this expression as follows. So we can factor x minus 1 times x minus 1 from x squared minus 2x plus 1, and in the bottom we get 1 times x minus 1. And we can cancel out two of these and just end up with x minus 1. So does this mean that x minus 1 is equal to f of x? Unfortunately, it does not. To see this, let us consider two functions. A function g of x, which is equal to the simplified expression x minus 1, and the original function f of x, which is equal to x squared minus 2x plus 1 over x minus 1. Let's evaluate these at x is equal to 1. So at x is equal to 1, we get g of 1, which is equal to 1 minus 1, which is 0. And f of 1 is equal to 1 squared minus 2 times 1 plus 1 over 1 minus 1, which is equal to 0 over 0, which is undefined. So we know that f of 1 is not equal to g of 1, which means that f of x is not equal to g of x, and from that we know that f of x is not equal to x minus 1. Some of you may remember from before that we can write f of x as a piecewise function since it's not defined at x is equal to 1. We can write it as f of x is equal to x minus 1 when x is not equal to 1 and undefined when x is equal to 1. But we do have this function, newly defined function, but what do we do if we want to find out what happens at f of 1? To do this, we're going to use the concept of limits. Limits are arguably the basis on which almost all of calculus is built, but despite that, they're probably one of the easiest concepts to understand. So to find out what happens at f of 1, let's look at what happens as x gets closer and closer to 1. So we're going to find out what happens as x gets closer and closer to 1. We write this in calculus as x approaching 1, and this little arrow over here, let me just do that in a different color. This little arrow over here means approaches. So we have to find what happens to f of x as x approaches 1. We're going to do that from two different sides of x is equal to 1. So first we're going to do it from the left-hand side of x is equal to 1, and then we're going to do it from the right-hand side of x is equal to 1. So from the left-hand side, we can plug in numbers like 0.9, 0.99, 0.999, and 0.999. So you can see that x is getting closer and closer to 1, or x is approaching 1. And plugging these in to f of x, let me just rewrite that function over here. F of x is equal to x squared minus 2x plus 1 over x minus 1. So plugging these values into f of x, we get negative 0.1, negative 0.01, negative 0.001, negative 0.0001. So we can see that f of x is getting closer and closer to 0. In other words, f of x is approaching 0. Now, as for the right-hand side, we can plug in the values 1.1, 1.01, 1.001, and 1.0001. And you can see that these are getting closer and closer to 1, so x is approaching 1. And when we plug these in to f of x, we get 0 0.1, 0 0.01, 0 0.001, and 0.0001. And again, we see that as x approaches 1, f of x is approaching 0. We write this as the limit as x approaches 1 of f of x is equal to 0. This LIM is just short for limit. Now keep in mind that this does not mean that f of 1 is equal to 0. It just means that f of x gets very close to 0. It's very close to 0 as x gets very close to 1. Very close to 1. We can also see this graphically. So as x gets closer and closer to 1 from the left-hand side and the right-hand side, we can see that the function is getting closer and closer to 0. And this dot signifies the whole, since f of 1 is undefined. And again, we write this as the limit as x approaches 1, which you can see it's getting very, very close to 1, of f of x is equal to 0. The general notation for this, where we have an arbitrary function f of x, the limit L, and x approaching an arbitrary point A, we write this as L is equal to the limit as x approaches A of f of x. This is a very important equation to remember, as you will see it over and over again in your calc classes. Now that we know more or less what a limit is, let's get into a caveat of limits. A function does not always need to have a limit at a certain point. The limit, let's call it L again, only exists if the limit from the left-hand side of A, let's call that L sub lowercase l, is equal to the limit as x approaches A from the left, and we use this subscript over here, this minus subscript, to mean from the left. So this limit from the left of A has to be equal to the limit from the right. Let's call that L sub lowercase r, which is the limit as x approaches A from the right of f of x. And again, we use this plus notation for from the right. Let's look at a function where this is not the case and the limit does not exist. Consider a function g of x, which is equal to x minus 2 when x is less than 2, and x plus 2 when x is greater than or equal to 2. And we want to find the limit as x approaches 2 of g of x. Let's do this in tabular form first. So from the left-hand side, so as x approaches 2 from the left, so from the left we can plug in the values 1.9, 1.99, 1.999, and 1.999, and plugging them into the function g of x, we get negative 0.1, negative 0.01, negative 0.001, negative 0.0001. So we can see that as x is approaching 2 from the left, g of x is approaching 0. Now, from the right hand side, so as x approaches 2 from the right, we can plug in the values 2.1, 2.01, 2.001, and 2. Quadruple or triple 01. And we can see that as x approaches 2 from the right, g of x has the values 4.1, 4.01, 4.001, and 4.001, which means that g of x is approaching 4. So the limit from the left-hand side of g of x, which is the limit as x approaches 2 from the left of g of x, is equal to 0. And the limit as x approaches 2 from the right of g of x, which is L sub r, is equal to 4. And we can see that these two are not equal. So we can conclude that the limit as x approaches 2 of g of x does not exist. And this D and E just means does not exist. We can also see this graphically. So here we have the graph of g of x, and you can see that it's approaching 2. So x is getting closer and closer to 2. So from the left-hand side, we can see that g of x is getting closer and closer to 0, which means it's approaching 0. And from the right-hand side, as x approaches 2, we can see that g of x is getting closer and closer to 4. So again, we have the limit from the left, which is equal to 0, is not equal to the limit from the right, which is equal to 4. So again, we can conclude that the limit as x approaches 2 of g of x does not exist. And that's all I have today. Thank you for watching, and I hope it helped.